Hello wonderful person, this is Anton, and today we're going to be discussing a groundbreaking study on something that we kind of take for granted and something that's underneath our feet, but also something that's so incredibly enormous that its scale is almost impossible to comprehend. Something that's technically referred to as AM fungi, or Arbuscular mycorrhizal fungi, that though most of us have probably heard of before, is still something that nobody expected to be so enormous and so extremely influential on the planet. As a matter of fact, let me first help you visualize this by using this map you can find in the description. Because despite this resembling planet Earth and basically all of the continents on it, what you're actually seeing is a fungal map, or a mycorrhizal infrastructure map, which essentially shows us the overall density of mushrooms in each of the locations on the planet. And, well, as you can see, it kind of describes planet Earth pretty good. As a matter of fact, I was kind of even surprised that some of them even exist in Antarctica. And though most of the videos on this channel usually describe these massive structures somewhere out there in outer space, this recent study published in the journal Science revealed that the Earth's soil contains this enormous circulatory system, or this fungal network, that's ridiculously mind-blowing. As a matter of fact, if you were to take all of this and stretch this out into a single strand, or basically if you were to somehow unentangle all of this, it would stretch for approximately 110 quadrillion kilometers, or approximately 1 billion times the distance of Earth to the Sun, which represents 10% of the Milky Way galaxy. In other words, if you were to somehow take this underground network and stretch it across space, it would actually resemble a small galaxy in size. But what we have in this study is really important because we now have an actual map, or the first global map, of this arbuscular mycorrhizal fungi network, with the data suggesting that we've actually been overlooking one of the most important components of the planet's life support system. Once again, something that we knew existed, but something that we dramatically underestimated. And so let's discuss all of this in a little bit more detail, talk about exactly what this network represents, but before we dive into this map, we actually need to understand exactly what these organisms are, or basically what are these AM fungi, and what exactly is their role on the planet. Well, in some sense, they're obviously mushrooms. And as we discussed in some of the previous videos, scientists today believe that mushrooms, or fungi, are basically some of the oldest organisms on the surface of the planet. They were potentially the first to colonize the surface, and plants very likely followed afterwards. And it was most likely the collaboration between fungi and plants that allowed them to eventually take over the planet and spread on every continent. But when most people think of fungi or mushrooms, they think of something like this. But these are basically just fruit above the ground. The real body of the fungus, just like with trees, is actually in the soil underground and consists of microscopic thread-like filaments referred to as hyphae. And quite a lot of these different types of hyphae tend to form different partnerships with plants, with these arbuscular mycorrhizal fungi being able to form a symbiotic relationship with approximately 70% of all land plants on the planet. And we know that this is most likely one of the oldest such relationships. It's at least 450 million years old, and possibly even older, and was definitely one of the main reasons plants were able to colonize the planet following fungi. Or basically, if it wasn't for the help from fungi, plants would unlikely to succeed. And the actual deal in this case is pretty simple. Plants produce carbon through photosynthesis. Fungi cannot do so, but fungi can capture something that plants can't. And so in exchange for carbon, the fungal hyphae, which can actually create these large networks and expand through enormous volumes, can then explore a lot of tiny crevices that a typical plant root cannot reach, and provide plants with a lot of essential stuff. For example, 80% of phosphorus, 20% of nitrogen, and even a large amount of water seems to essentially come through this trade network formed by these fungi. In fact, normally, these networks increase the foraging area by at least 100 times, allowing a typical plant to become extremely efficient at absorbing nutrients from the soil, Once again, without these fungi, a typical root of a plant is only approximately 1% efficient. But all of this is underground, and all of this is pretty much invisible. And so how exactly was all of this discovered? Well, that's actually what makes this study so significant. Here, scientists were able to image a lot of this and map these networks in a way that was impossible previously. And so to build this enormous map, the international team of researchers, including the Society for the Protection of Underground Networks, also known as SPUN, assembled the data from more than 16,000 soil cores collected in a lot of different places on every continent. But here they did not stop at field samples and actually used some additional techniques. And specifically they used robotic imaging to track over 300,000 living fungal threads in order to predict the overall fungal density for every square kilometer on the planet. Or just to rephrase this, they used the observations of how these fungi grow to try to predict how they would spread underground. And so the combination of soil sampling allowed them to create an enormous dataset involving over 4,000 different sites, with the results basically being staggering. Apparently, in just 1 teaspoon of healthy soil, you can have up to about 10 meters of these fungal formations, or fungal filaments that create these enormous networks. And collectively, the fungal network seems to represent 300 megatons of carbon. That's about 4 to 6 times more mass than all of the humans combined. But perhaps the most surprising discovery in the study is where some of these densest fungal forests seem to be located. In other words, where they seem to be the most successful. And usually when we talk about carbon storage, we tend to focus on big tropical rainforests. But as this map reveals, that's not actually the case. Here's actually a really good example from Asia. This map reveals that wild grasslands seem to be the true hotspots for this underground world or this underground fungal life. With, for example, places like sod wetlands in South Sudan or even the Florida Everglades basically being some of the most enriched places on the planet. In contrast, in Brazil, as you can see, the Amazon is not as enriched, and only certain places such as extremely high mountains, for example the Tibetan Plateau, or certain deserts like the Sahara, seem to contain almost none of these formations. But locations like prairies, steppes, and savannas seem to hold approximately 40% of the world's arbuscular mycorrhizal biomass and represent some of the healthiest soils on the planet, which is actually really important for understanding the carbon cycle on the planet because this is a little bit different from what we thought before. Since the grasslands store so much of their carbon underground, and especially inside these fungal networks, and since we know that grasslands are generally extremely resilient to wildfires and even droughts, generally they seem to contain a lot of hidden carbon. But this study actually points out the troubling reality. Grasslands are also being actively converted into farmlands approximately 4 times as fast as various forests. Mostly because it's just a little bit easier to rip out a bunch of grass compared to cutting down a tree. Which means that a lot of these fungal networks and a lot of carbon inside of them might become disturbed as a result, thus changing the overall carbon cycle in ways we cannot predict yet. And the study also highlights a relatively serious threat to our food security. And that's because farmlands and managed croplands tend to have dramatically lower density of these fungal networks compared to natural conditions. Usually it's at least 50% lower than any natural ecosystem. And so by using a lot of modern practices, such as, for example, using excessive fertilizer or even using fungicides, can dramatically disrupt and suppress these networks and essentially create conditions on the planet which can then cause a lot of these networks to decline, with the soil essentially losing its natural circulatory system, making crops overall less productive and making them more dependent on chemical inputs. With researchers even arguing that we must learn to protect these networks because they seem to act as hyper-efficient supply chains for a lot of different plant life. As a matter of fact, inside these fungal pipelines, carbon and various nutrients move at speeds that, if scaled up to human size, would actually feel like traveling at 400 kilometers per hour. Or essentially these networks provide a lot of nutrients extremely efficiently and do so in a way that it actually creates what we now refer to as wood wide web. Or basically it's something that allows trees and a lot of different plants to facilitate resource exchange and even support each other in times of danger. But in this case, this particular study mostly just tells us where these fungi are and not exactly what they do, because their actual influence and their actual importance is still poorly understood. And so, as scientists like Eduard Evangelisti points out, we still need to learn, and hopefully learn quickly, how these hyphae and these fungi grow, and what effect they seem to have on a long-term carbon cycle. So there are still some massive gaps in our data and in our understanding, and particularly in certain regions like the rainforests and deserts. Even though on this map they do appear relatively empty, it's actually because these locations have not been sampled yet. And so for all we know, maybe even right here in the Sahara Desert, there might be some fungal networks that are just waiting to be reawakened, because we know that back in the days, Sahara Desert used to be full of life and contained a lot of vegetation. And you can learn more about this in one of the videos in the description. And so, in conclusion, well, this research right now definitely shifts our understanding of mushrooms, and specifically these AM fungi that we know exist pretty much everywhere. And it also helps us see soil not just as dirt, but as a living infrastructure that regulates Earth's climate and provides for a lot of different types of life on the planet. And so by making the invisible visible, this map helps us explain how this potentially works and takes us just a little bit closer to understanding so much more about our planet and the life on the surface. And because fungi have been mostly ignored by a lot of different studies in the past, and also because we don't really know about them just as much as we know about plants, here the research suggests that it's about time we change the trajectory and try to understand their significance a little bit better. On that note, once we learn something else, we'll come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying a Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.